know some of you are still having a little difficulty with absolute value and radicals. So let's start with the basics. Does the square root of x squared always equal x? If you say yes, it has to be true for all real numbers. So the best thing to do is to plug in some actual real numbers. So let's start with the square root of, we'll say 5 squared. So what is the square root of 5 squared? Well, we know that that's 5 because the square root of 25 is 5. So it works there, it's true. Now let's try 0. So what about the square root of 0 squared? Does that equal 0? Hopefully you're saying yes. So far it works for positive, it works for 0. Now what we need to check, which is usually the culprit, are negatives. So what if x is a negative 5? Does that equal negative 5? Because remember, we're just plugging in a value for x. So we know that negative 5 times negative 5 is actually going to be the square root of 25. Well, the square root of 25 you've been doing for years is 5. So notice that if x is negative, when we take the square root of x squared, it is not a negative 5. So when you see the square root of x squared and you're thinking it's x, it's actually the absolute value of x. Because if you notice right above the square root of 25, it's not a negative 5. It's the absolute value of negative 5. So a few things I want to point out. This is an even root, or you can think of it as an even index. Okay, now let's look at an odd root, and let's just do the most basic one. How about the cubed root of x to the third power? So most of you, your natural instinct is to say, well, that also equals x. And my question to you is, does it always equal x? Well, you can try your positives. So let's plug in 2. If you have the cubed root of 2 to the third, do you get 2? And you do. What about if you take the cubed root of 0? Are you going to end up with 0? You are. Well, what about if you take the cubed root of a negative 2, so the quantity negative 2 to the third power? Do we get negative 2? And in this case, we do, right? Because the cubed root of negative 2 times negative 2 times negative 2, we're looking for 3 of something. And we have 3 negative 2's underneath that cubed root. So yes, the cubed root of the quantity negative 2 to the third is negative 2. So with odd roots, you never have to worry about doing the absolute value. It's only with even roots. Now, it would be great if that was it, but let's do some more complicated even roots because we need to talk about when is the absolute value actually necessary. So we've talked about how the square root of x squared is the absolute value of x. Okay, and we've plugged in some numbers. Now, let's talk about the square root of x to the fourth power. So most of you, kind of your natural instinct would be to say that the square root of x to the fourth is x squared. And so my question to you is it always x squared? Well, this is an even root. I do want to point this out. This is even because there's an understood 2. And let's still plug in numbers. We know that positives aren't going to matter, right? Because positives are going to give us a positive. We know that 0 to the 4th, if I were to take the square root of that, I'm going to get 0. But the issue is our negatives. So let's look and plug in a negative 2 to the 4th. Well, is that going to be negative 2 squared? Because remember, all we're doing is plugging in negative 2 for x. Well, think about it this way. Underneath the square root, aren't you going to have a positive 16? And does that equal a positive 4? And it does. So even though this is an even root, when the exponent in your answer is even, the absolute value is not necessary because x squared, no matter what the number is, it's always going to be positive. So whether you put those absolute value there or not, they're not necessary with that particular even root. So when you're dealing with even roots, there will be times where you don't need the absolute value. Now let's do another one. Let's go a little further and say, okay, what about the square root of x to the 6th power? So the square root of x to the 6th power, your natural instinct is to say x to the 3rd. But we need to determine, do we need those absolute values? So plug in a negative, because that's really where the problem usually lies, right? So let's look at this. And I'm going to put a question mark here. When I take the square root of the quantity negative 2 to the 6th power, does it equal the quantity of negative 2 to the 3rd power? Well, when you think about this, under the square root, when you take a negative number to the 6th power, aren't you going to get a positive number? And then when you take a negative 2, that quantity to the 3rd power, isn't that going to be a negative 8? So we know that can't be true. So when you have the square root of x to the 6th, it is x to the 3rd, but it's the absolute value of x to the 3rd. So remember, this is an even root. Now what I want you to notice is notice this exponent in your answer. It is odd. Well, that follows the same pattern as up above. Here you have an even root, and the x to the 1st was odd. So if you're looking for a pattern of when you absolutely must have the absolute value, it's when you have this even root and your answer comes out with an odd exponent on your variable. Okay.